Let me introduce myself for a bit. I'm Alex Thissen. I'm from the Netherlands. I'm a cloud architect there. I work at a company which does a lot of consulting with a number of customers in the Netherlands, small, big ones. I know that Romania and the Netherlands are, closely related economically and all. Not sure if you've been there, but yeah, the Dutch people in general are very tall, so they just asked me, should we put the screen a bit further behind, but I can just look over it. In general, Dutch people are tall, and if you've ever been to the Netherlands, maybe you've noticed that a lot of the Netherlands is below sea level, and we have the water protection system. And whenever that breaks down, and it did in the 1960s, a lot of the Netherlands will flood. And we think that's actually the reason why we are so tall, because it's, kind of natural selection happening. Anyways, you'll know, we're the tallest nation in the world. There's also a long title. More and more got into the title, but I would like to take you on a trip to know what it's like to put instrumentation in your code. All right, there's this list on the Microsoft website, on the documentation website, that talks about DevOps and that it needs monitoring. So who of you, and don't be afraid to raise your hand, but who of you is doing DevOps or something similar while developing and running your code? And now remember, you can raise your hand. It's cool to be a DevOps. My t-shirt says, you build it, you run away. That's usually what happens before the DevOps stuff. But if you want to do real DevOps, you need to do, maintain it and run it in production. And that's actually where the part with instrumentation comes in. So I picked a part of the checklist that is on the Microsoft website, the part related to monitoring. And I've starred out these 3 top ones. That's what we'll focus on mostly during the session. Okay, there were a few people that raised their hands. Now let's see if the clicker does something. Yes. So the people that raised their hands, that's you. You're the hero in this story. The other ones, you can still switch sides. But anyway, if you're a DevOps engineer, what you'll do is normally you will pick up work items from whatever work item tracking management system you have, and you'll start to work. You'll do some coding, and that's where you cycle fast. So you want to run in complete isolation. You'll do locally what you'll do on a bigger scale in production later on. But this is your inner loop. So you'll try it out, you'll debug it, you'll test it, unit test it, and once you're comfortable with it, then your automation kicks in. What does it do? First of all, you push out your code to a Git repository. Might be some other one, but at least it goes into a repository. You will probably run all these automated tests. And finally, you have a build and release pipeline where you push it out into production. Now, this is what sometimes becomes a black box, like a black hole. You put it there and you have no idea what it's doing. You might recognize this, that it's running in production, it's doing stuff, but once it starts breaking down, you have no idea where it's going. So that's what we want to change. We want to change this to, and the clicker is not working all the time, we want to do a feedback loop. That's the other loop. We want to close the loop from production back to what we're doing on our development machine. So that's why we want to gather some instrumentation data, all the things that our application could be telling on how it's running and what it's doing in the place that it's running in. And that's where you want to monitor. See what's going on, get alerts when things are going bad, at least have some idea of what is going on, and that's all the way back. Because as soon as you see something happening there, you'll get alerts, you'll get attention, and then you start investigating what is happening, and you'll put it into your work items again, probably pick it up straight away, and then all of a sudden you're this healthy DevOps engineer because you've closed the loop. You put something in production, you change something, and you know what's going on. All right. Now this becomes pretty tricky if you're building distributed applications, especially if you're running in the cloud and you're doing, Dapper, for example, or any of the microservices-based architectures where there's lots of moving pieces going on, leveraging all these cloud resources and putting it all together to build this complex solution. That's where it becomes tricky to get an overview of all the moving pieces and how they are doing. You want to get all the data together, correlate it after you've collected it, and then say things about what is happening, how are people using the application, how is it performing. We need to log certain information to see it later on, so we can trace back in time. We want to do traces across all the calls that touch all the moving pieces. And in general, you want to just know if your application or your solution is being healthy. Now, there's quite a number of things out there, application performance monitoring systems that do that. I've only listed a few. These are quite arbitrary. There's many more, and all of these try to tackle the problem of how do we get all the data in and give you insights into what is happening in your landscape. Now, this session is a bit emphasized towards Azure and .NET Core, but most of the things that are talked about that you do in Azure with certain logging frameworks, for example, most of the things are replaceable and it doesn't tie you in. But I'm showing you with, for example, Azure Monitor, just to know what it looks like and what the requirements are that you will need. So you have an understanding of the things that you should do or select, the requirements that you have when you want to build something similar. But in no means, any shape or form, are you required to do Azure Monitor or any of the other things that I talk about. Azure Monitor, in this case, will do the aggregation of all the data, give you some monitoring and insights, analytics capabilities. And I'll show you where all this information comes from. So first, if you're using Azure, you have an Azure tenant, which is an Azure Active Directory, and it sends out all this Azure AD log information. That gets sent up to Azure Monitor. Same happens for your subscription. It has activity logs of all the things going on. And you have your Azure resources. And this is where it starts to get real. Azure resources could be any of these things and more, like virtual machines, the databases you have, all the code that you build, deploy, and host, whether they're hosted in an app service or maybe in a Kubernetes cluster, doesn't really matter. They send out all this diagnostics information. And on top of that, you will run your cloud application. And it can be a service, a web API, it can be a website, any of those things. But we'll look at .NET Core, and we'll look at some of the NuGet packages that you will use and some frameworks to get the application log, the tracing information, and all the metrics out and push it all into Azure Monitor. A lot of the stuff that's going on in the bottom part of the slide is what is called a control plane, where things are being controlled and sort of administrative things getting created, things getting done. But once the data starts flowing, you talk about your data plane, and that's actually where we're mostly concerned, because that's the stuff that we are building. The rest we get for free, but in this area, this is where you need to make your investment. So this is what we'll talk about. So let's have a look. So we take the top square, we zoom in, and then we get all these things, like the logging, the tracing we want to get in, we want to get the metrics in, and finally we talk about some health and health information from your application. And you will need a certain set of NuGet packages. Most of them are included by default, but you might need some additional ones. And then you will have these capabilities in your application that sends out that particular information. And it will go out to something that collects it. Because once you've collected it, you can monitor it. And the monitoring thing can do other stuff like monitoring the health status. So that's something that's actually being pooled, where all the other things are being pushed out into the collection. You can do other things that, like you can have your health information being pushed as metrics. You can have your logging information being traced and your trace information being logged. like the exotic stuff, but there's a lot of combinations and things that you can do. But once you have the monitoring in place, then you can do your analytics, you can add alerts on things taking a certain trend, you can have insights with dashboards and start analyzing and profiling, and even sending out this metrics stream that you can pick up somewhere else in your system. So once you get it all in, the possibilities are almost endless of what you can do. Now, one of the things I'd like to emphasize is that once you start doing instrumentation, make a good distinction on what is what, because these things sometimes get meshed up and mixed up, because logging sounds like tracing, and tracing might be sometimes logging. But logging is about what happened, and you actually want to have a historical record that's something that is in the log, like the ships used to have. They would write something in a ledger, and every line would be a log entry. Tracing, however, is some information that's being shout out. It's usually for profiling, tracing, or debugging scenarios where you want to have a really deep insight in what is going on. And it's a lot of information going out, and you don't want to have all of that noise inside of your log, because it doesn't really matter. Trace is typically, you look at it when you're interested, and otherwise it just disappears and evaporates. The metrics are numerical data that you can collect and do averages on, statistics. So those are very good for charts. And your health information is good for monitoring your system, maybe by a cluster orchestrator that can look at your application and ask your application if you're being healthy or not. And then the auditing, I put it in for for sake of completeness. But auditing is like the stuff that you want to have logged because somebody did a certain action, and they might tell that they didn't do it. So it's a security thing to do auditing, so you can actually see who made a certain change. Okay, so let's dig into logging. And I know that most of you probably already did a lot of logging, so I'll go through this fairly quickly and show you some of the cool stuff that you can do. And then we move on to the other things. So just to get a sense of understanding, if we're talking about the same thing, you have your .NET Core application. You want to log certain events of things that are happening. So that's the log messages that you want to send. You use a logging framework to get them out of your application, and you want to get them into a log provider. And it sounds like, why is it providing me some? Well, it's providing the log. You could also think of it as a target or a sink, because actually the log messages go in there. It doesn't give you anything like a normal provider pattern, except for access to the log. This has been in .NET Core 1.0 since the very beginning. It has evolved, and some things have changed, mainly concerning the bootstrapping of getting all the logging frameworks and all the filters, for example, in place, because there's also filters that you can apply. Now, there's a whole set of built-in logging providers that are out there. There's NuGet if you want to have other ones, but these are the ones that are available. And I put in a little, well, big code snippet there, where you can see how you just build up all the logging providers in your code. And you can have multiple, so it's not limited to one. You can just add application insights, the console, the debug, and even a trace source. And many, many more, because they're all listed there. That's what you would typically do. Then you've got your destination set up. And all you need to do is, with this LoggerFactory that's being constructed under the hood, they have all the log providers that are registered. And every time you inject something like an iLogger of T from the dependency injection system, it will have all of these registered log providers attached to the instance of the logger. So it's always injected into your code wherever you use it, but mostly that's your web controllers for the web API or your web pages, or it's some component or service that you're using that also is being constructed with dependency injection. Once you have the iLogger of T instance as a variable reference, it's injected into your constructor, you store the variable, then everywhere in your code you can use all these log methods with overloads that allow you to send out information. You see there's quite a number of them with log critical, log error. That brings us to the severity levels. Because if you log something, you want to indicate how important it is, how bad it is. And it goes up to from 0 to 5. It goes up and it becomes worse and worse. So the higher severity level you choose, the more attention you want to have. The categories are a hierarchical structure. So if you think of the category as a string, there's two mentioned, like Microsoft and a more nested one, Microsoft Hosting Lifetime. Those are categories, and you can filter based on those. So it's important to know that there's a hierarchical structure in there. And the iLogger of T, which is used most of the time, the T doesn't really mean anything except that they use the fully qualified name of your type as the category. So if you have something like the Leaderboard Web API controller's namespace with a Leaderboard controller inside, it will give you a category with all of those things. And that makes it easy to search for it, to filter on it, because you can filter on Leaderboard Web API, which is a service-specific one, or even your class. So it's good to use the logger of T, but you're not required to, because you can still use create logger and create a logger yourself, an iLogger implementation, and then you can just choose the category by an arbitrary string. Final thing, before we go into a little bit of demo, is the log filters. You can filter the log messages, like we just said. So if you want to have, for each of those providers, a filter, you can do a configuration section inside of your app settings JSON, but you can also do this from code. But in general, it's you have the centralized one for each of the providers, unless specified more specifically. So if you say log level, and then you can say for each of the categories what the level is that you want to listen to. It's like the volume knob. If you turn it down, you don't hear as much. If you turn it up, you hear much more. You would turn it up if you're debugging and you're like trying to troubleshoot. Then you want to have the lower severity levels because you want to hear more. The categories are listed there, and the severity levels are used as a means of filter. Default is the one that is always there, so it's a reserved name. But if you have multiple providers and you want to be specific about one of them, then you would say, okay, the special names like console, debug, application insights, then you can repeat the log level inside of it. And then you can set properties first, and you can also set all of the log levels. And that's how you can be really specific on what goes to which provider and how much ends up there. So let's have a quick look. All right, so what have I got? I've got a project here. Let me see if I can zoom in a bit. There we go. The main parts are this web API and a web application. So it's fairly simple, a front end with Razor pages and an API on the back end. And if you hit the home page, you'll get a list of high scores, which I'll show you. It's running in containers, so we're doing Docker Compose, and I'll show you later on what we're using to run in isolation. But it's spinning up the controllers now, the containers now, and it's hitting this endpoint. So I'll go through this, but just have a look. I put all these log levels here, just dumping these out to show you what ends up in each of the logs. So if we continue to do this, this is actually what we just did. We hit the web API. We can also hit the front end. There we go. And I need to remove the breakpoint because, as Martin showed, you can do poly. And if it doesn't react fast enough, you can do graceful fallback, so that's in there. But these are all the high scores for various games. And let's have a look at what is happening there. So if I look at all the containers that I have running, it's kind of hard to see, but and it's scrolling like mad. Oh, there we go. It's this one. The leaderboard web API dev, that's the one. It has this F2F. So if I do docker logs F2F, I will get a dump of everything that's happening there. We hit it a couple of times, but as you can see, we only have the critical fail and warn messages showing up. So not all of them, because we had more. Now, that it doesn't show you everything has to do with the logging filtering that is being set up. So if we go to the app settings, you see that the log level in general is information and warning. For console, it's warning, error for Microsoft, and information. So we will only get warnings and up by default on the console, not everything. If we want to hear more, we could change this to information or even to debug. This will get read automatically. It is done in a configuration in your startup. This is the old way of doing things. In .NET Core 2.2, you had the create web host builder. And if you haven't made the switch to 3.0 yet, it's already introduced in 2.2, but now the default way is that there's no more distinction between a web application and a generic host. Everything is being generically hosted, even if you have a web application running inside of your host. That also means that you can do a lot of setting up inside of the host building part. So you can configure your app configuration, and you can do the configuration of your logging. And what you will get is a builder, which represents the LoggerFactory. And here you will do all of the things that we spoke about. So you will probably, if you want to be precise about all the providers you have, you will clear out the ones that are pre-registered. You add the configuration that we saw from the app settings JSON. You might set a minimum level, because if they don't figure out with all the rules that you put in your JSON file, then they will they fall back to this information level. And then you just add each of the other ones, like application insights, for example, the console, you might add those. And you can add filters as well, where you can say, okay, just for any of the categories, set the log level to information in the case of application insights. If you start using them, then in your constructor you will have, you can choose two things. You can have the LoggerFactory injected, and with the LoggerFactory you can create each and every logger of your own liking, even the ones without the generic, so you can specify your own category. Or you can just inject logger of T, where T in this case is the leaderboard controller. And then you have a specific type, always the same. So you can choose whichever way, and then it's every place where you want to have the logger, it's already stored in the field, and you can use it, and even you can assume that it might not be there with the Elvis operator. Okay, that's for this part. Let's go back. Now, a long time ago, I studied physics, and while I was thinking about, if we have all this log information, we want to send this information out, and that's kind of good because we want to read it. But sometimes you want to approach it a bit differently. So what it made me think of is quantum physics. I'm not sure if you ever heard the story about Schrödinger's cat. It's about the duality of particles and waves, or quantum state up or down, and it's kind of in between. So the cat, the thought experiment is the cat in a box. There's poison there, and then while the box is closed, it might eat it or not, so it might be alive or not. So actually it's both, half alive, half dead. And only when you observe it, you force it to be either one, because when you see it, it's alive or dead, but not both. And that kind of made me think, okay, so if we are doing log messages, sometimes you want to have the human readable description, which allows you to read it as text and then interpret it by its meaning, to give you understanding of what happened. But in other cases, you want to have contextual data that is machine written, so you can do queries or analysis on it. And then you want to know what is inside the text that's normally inside of your message. So just imagine that customer 123 deposited 100 Lei to his account with this number. you are interested, you might be interested in the actual numbers. And normally you would do all these regular expressions to pluck it out, but it would be much easier if it would have the data, or readable, or both. So that's where semantic logging comes in. And if if you take away at least one thing of this session, and then it's start using semantic logging. Semantic logging is quite easy. It doesn't really change the way you do things, because you will still specify your log message, but it's a template all of a sudden. And as you can see, it says search limit. It doesn't say 0 for a positional parameter, like you do in the string.format, but it's a term. And this term is important. You need to think about that when you design your application, what those terms need to be. Because from an outside perspective, these should be logical. And there might be multiple log messages all over your application, and maybe even in other applications as well, that also have this term. So think about the terms that you choose. And as you can see, the parameter at the end, limit, doesn't have to match up. So it's just by order. So the limit goes to the first placeholder, and the next one goes to the second placeholder. That is what is happening. But the data is being kept. So the template is kept with all of the placeholders as keys, and the things like limit as the values for the keys. Now you need something that understands how to store that data, because you want to get it out afterwards. As you can imagine, the console application doesn't really know. It displays a text message and then it's gone. But if you have something like SEC or SAQ or Application Insights, they know how to store the message template as well as the additional data. And you can use either one of them, like in the duality, whatever is suitable for you at the moment. So let's have a look at that. So I'll show you how to add that. We'll go to the app settings JSON, and we go to program CS. So what I'll do here is I will do builder add sec. Now add sec, this would be enough normally, because there's overloads that have optional parameters, and this one, if we can get it to zoom in. As you can see, it says, okay, the server URL is normally localhost and a certain port 5341. You have API keys if it's an external SAQ server, but we want to use it locally. And I've added that to the Docker Compose file. Now, it's a bit too much to go in all the details, but this is where I create a composition for my leaderboard web API. That's the service I want to run. The front end, which is the web app. And then here we have the SQL Server database that I'm also running from a container, so I don't have to use that. And this is where I use an image for SAQ. So when I press F5, it spins up the API, the web app, containers for the SAQ logging, and for the SQL Server, all neatly combined. And I can do this from a plane, no connectivity, and you can still work and have everything close by. And you can do much, much more for running from containers. Very nice. As you can see, this is SAQ, that's the symbolical name of the service. And this is what I need to do here. So here I need to say HTTP, and then I need to say SAQ 5341. Because internally, inside of the Docker composition, it's being resolved not by localhost, but by the service name from the local DNS. So with this, we have a new provider, and it will also go there. We can add some filtering to that. So if I would go here and grab a snippet somewhere. There we go. We put that in. So we have log level, by default error, but for the leaderboard web API, we want to hear everything from debug. And if we run it now, we should be fairly okay, I think. Yes. Okay, so I see that we have the site spinning up again. We should be going to the SAQ and have a look here. This is from 1431, so my machine is 1 hour behind, local time zone in the Netherlands. But you can see that all these information from debug and up is actually being registered here. And if you have special log messages that use the template thing, and let's see where that's going to happen, that's in the leaderboard controller. We have this API version 2.0 that actually does retrieving the score list with a search limit, like in the slides. So if we call that one, let's do that. Here we go. We have API v2. We can run it with a limit of, let's say, 20. It will give as much as there is. There's no 20 at all, so that's good. And if we now go back to SAQ, we should be able to see that there's a limit of 20. But if we look inside of the log message, you can see that there's a search limit there with this data. So I can even do this, like search limit, and it gives me sort of IntelliSense, search limit bigger than 4. And it will give me only the ones with this number actually being bigger than 4, because if I do bigger than 1, I get more information from all of the logs. And just imagine this can come from anywhere in your landscape, because everything that's going to SAQ, you can search on the parameters, the keys that are in your message templates, and you can combine everything. So it doesn't even have to be this single message. It can be any message that has search limit in it. All right. So that's that part. There's more stuff, and in the interest of time, you'll get the slides. I'll skip over it, but there's more concept like logging scopes. If you want to combine information into multiple log messages from a certain scope. There's some guidance. Separation of concerns. In your application, you should never decide if you write a log message, this log message will go here or will not go here, or will be sent to, because you shouldn't care. You should just say log this with this level for this category, and the filtering and the log providers will take care of the rest. I put a quote in, rule number 11 from a 12-factor app. It's one of the places where you can see that this is actually a good thing. Choose your log severity level carefully. If you're doing DevOps, you will have PagerDuty, and you will be called. Just imagine if you have a try-catch block and you catch an exception. What would you log inside of the catch? Who's going for log error? Okay, you will be called in the middle of the night. And it might just be that there's like the timeout rejected that Martin showed. If you have that and you log it, you'll get those quite frequently because you're retrying a couple of times and ooh, now it works. But it will mean that there's a lot of errors being logged. But actually, you're pretty okay because you caught it. You might want to log it as information because it might be good to see afterwards how many of those messages you got. But just, you know, that's the consideration you need to make. Also remember that the log messages are technical stuff. You don't have to localize them. There are analyzers that tell you to put them somewhere other than in quotes, literally inside of your code base. But that's more for reuse than for translation in a certain language. And if you don't know yet, just log too much because the filtering will take care of it, and otherwise your tooling will help you out. There's other frameworks that you can use. It's whatever you like best. There's a couple of ones that are fairly popular, like Log4net and nlog, and one of the most popular I found is Serilog. And Serilog has a very active community, so if you like that one better, feel free to use that one. Just make sure you tie it in, so do add Serilog. You can also do it the other way around, but add Serilog allows you to do the iLogger of T all over the place. So you only need to change the program CS and everything will stay the same. Then we go to tracing. I'll be brief here because this is if you want to do high volume output of information. For example, I've had this at a customer where they had this calculation engine and they wanted to know which parts of the calculation engine, which was the complex object model, where they all wanted to see where the code was going, where it was flowing without debugging. But they wanted to know what was being touched. That is typically something that you don't want to have inside of your log because you don't really care to read back from 5 days ago how the calculation engine just got called internally. But it does give you an API inside of .NET Core that does a lot of publish subscribe. Like I said, you just output your trace and there might not even be someone listening. It's the system diagnostic namespace. It's a fairly old one. It has been ported from .NET Framework into .NET Core, and it's now feature complete. Under the hood, it uses activities, and that's a big thing. The activities are kind of cool. If you want to use the tracing infrastructure, you have the debug class and you have the trace class. So you might have seen them, debug write line or trace write line. The trace has a more modern version, which is the trace source. And as you can see, both have the notion of trace listeners, much like the providers from the logging. You can register one or more, and it will be sent out there. You can do filtering on them again. You see that the trace has this write and write line, but it also has the trace error, trace warning, trace information. And the trace source, where you can have multiple, has other methods, like trace data and trace event. Trace source is an instance. Trace on the left side is a singleton, so you can sprinkle it everywhere in your code, which makes it very convenient. You don't have to dependency inject it in each and every small class that you might be using. The activities are contextual data that is ambient, so it just lives there, and it's there available through activity.current. It has tags, and it has a baggage, like some stuff tags that will travel or will not travel. It's thread safe and it's async aware, so it travels from thread to thread, and you can always ask for activity current, and while you're in an activity and you're making calls to other pieces of code, you'll stay within the same activity. And even if you jump from one machine to another, from one component to another, it does know how to correlate things, because across the wire, some of that data is also traveling. And Application Insights, as an application performance monitoring platform, actually uses these activities to correlate stuff. You can do the Microsoft internal terms of correlation, or you can do W3C tracing, the new one. And that will make sure that if you do have calls from one front end to an API to another API, you can actually see the flow of all the information, and I will show that in a bit. It has a parent-child relationship, so you can have nested activities that are part of a parent and ultimately up to the root. A bunch of trace listeners for your reference. Let's not look at that too much. I will quickly show you what that looks like. So inside of a controller, let me see where I have it. I think I have it here. This is what you would typically do, trace.trace information. This is just noise, just outputting that this method is being called. This might be like a web API call that's being made. That's probably also logged through request logging. But this could also be inside of a calculation engine, as the example mentioned. It does output the information. This doesn't do semantic logging, because this is tracing. This is just fast and much information. Where does it end up? It ends up wherever you send it to go. So you can add these trace listeners, and you can just say, okay, send it to console, send it to application insights, or whichever other provider that you have. This is the static method. You can also do the trace source and have that injected. But the trace is nice because you can just put it somewhere and it will do the tracing, provided that you have for the builds, and I need to stop it to show you, it needs to have the trace constant set. If it's not set, it will not output anything. So that's a way you can, do conditional compilation where you have or do not have the trace built in. So you might say we do it for profiling on the tester environment, but once we go to production, we leave this kind of stuff out or leave it in. The debug allows you to do the same thing with the debug.writeLine and all the other stuff, but that you do want to remove. Okay. I'll be quick on the health monitoring. Actually, let me skip that. Or do you want to? Well, I can be. Well, I'll run out of time. But okay, let's do this very quick. You do have an extension method on the registration of your services that's called add health checks, and then you add all these health check rules. And you can do sync and async methods, and you can do specific resources or dependencies that you have, like SQL Server or some external URL that you will call. Once you make a get on the endpoint that's being registered in your middleware, you will get a health report that's being built internally. So it will just go to each and every one, assuming that we're okay at first. It will check if the async returns and I'm healthy, the async is healthy, the database is not responding quite as fast, so that's a degraded. It might go bad, it might not, but it's point of attention. But if something can't be reached, then it turns red and the entire report turns red, and you get back a 500 instead of a 200 okay, and you could output more or less details of what is actually going on. That's the health endpoint. The cool thing about it is it's an endpoint that's being called, and you can have a monitoring solution just looking at it every 10 or 15 minutes to see what's going on. There's another thing where you can just push out the information to a publisher, which is publish subscribe, and it's actually just pushing out that information into something that's listening. And it can be Prometheus, Datadog, what else was there? App Insights. There's 4 of them now. And they will just push that out. This is for live listen, so this is where it's being used. I'll skip this. We need to look at application insights for a bit, because where it all comes together is, if we go back to the picture before, you already saw the icons. If you do a completely Microsoft topology, then at the bottom you will have App Insights and Azure Monitor. And application insights is very cool, because if you start using that, then in your web application you can put some hints there, so it can actually track everything that's going on in your web application. In your web API you can have the same, and it can follow the HTTP requests. And in your background services that are all .NET Core, you will also get extra information. And it was all collected into application insights and give you really rich telemetry and information on your application and how it's doing. Application insights, it was already in there. We saw the add application insights for the logging part. You have a trace listener, so that's where those 2 worlds combine. And then finally, you can even have telemetry information or metrics, where you use the telemetry client to send out specific information. Now, let me show you what this all leads down to. So we will run this. And we will go to the website. This will spin up in a bit. There we go, that's the web API. This is the front end. That's also working. So I've hit these things a couple of times. I will also do this one a couple of times. So we have some sort of load. And if we go to application insights, it's all being pushed to this instance of retro gaming logging. And first of all, you will get all the telemetry data in, and you can build an application map. And the application map gives the topology of everything that's being collected all over the place. So let's see if that pops up. If we have a good internet connection. Okay, there we go. Now the cool thing is that, and it's a bit smallish, but you see that there's the retro gaming web app making calls to this instance here. There's 2 calls now, 50% succeeded, 1 call didn't succeed. And then you have SAQ that we're calling to, and we have the SQL data, the SQL server, which is local now, but even if it's on Azure, it will just call out and it will trace everything and see where everything is going. Once you select one of these, you can look at the details, you'll get some of the log information. And this will allow you to drill down even further in everything that's going on. There's a couple of things that you can do from here, and I'll quickly start this one as well. You can have a live metric stream, so we will start connecting to the server. It will connect to it and hook up all of the registered things. So now there's 2 servers online. And if you look at the bottom, the servers that are there, they're weird numbers. Those are the 2 containers that is running my .NET Core code. If we now go back to the front end and run this, you need to take into account that application inside gathers everything, prepares the data, and then has it available. So it's not immediate, but the tracing is usually pretty okay. So we have a lot of tracing information. We should be getting the critical messages, the error messages, and the messages. If we go to the 2.0 version, we should also get new. And I'm so close to the screen that I can hardly see it, but there should be the 20 should be popping up. There we go. There. And you can see that there's the search limit there. So it is doing this semantic logging, which allows me to go here to the log. And the logs is log analytics. And when you're here, you can do queries and you can run traces. Traces are all the things that we put in our logs and that end up on application insight, which pushes it to the Azure monitor. But here we have the informational message. We need to sort this by time, and this one is a bit slowish. So some of the things will only be coming in after a while. But you can see here they're retrieving the score with a list of 20. So I can do these queries here where it say where custom dimensions, that's where they end up. And then I do search limit equals 20, for example. And if I run that one, I will only get the messages that have that inside. And I can do much complexer queries. I can also see the dependencies that I have if I run those. The dependencies are the underlying information that is being used in the application map because it's showing a lot of information. So if we go back to the application map, and let's refresh this. Let's take this one. I can view it in the log, investigate the performance. It will give me end-to-end tracing, so I can you can see all the things that came in, all the requests. I can look at the samples, and even for each of those samples, which are, for example, a get v2, I can see the correlation of everything that is happening there. Or if we go back and pick another one, let's say one that hits the database. I think it's this one. You get to see all the information, the web API calling from the local host to the web API, to internally, to the SQL Server. So you get all this rich tracing information because we put it into the instrumentation of our application. The key part there is to use, during startup, you need to add telemetry information. And it's this one here. This is the big thing. Your service collection should be configured with the application insights telemetry. If you're debugging or developing, add this one because it will flush everything immediately. And that's where you hook everything up. And then inside of your code, you can do neat stuff like this one. You can track events, like we receive the high score. We can track the actual values that go with it. And we can start new activities. And the new activities, together with operations, allow you to show additional things that you think are relevant for your application. So let's go to the website as the final thing, and then I'll open up for questions. So if we go here, and we go to the Swagger UI, we can go to the scores, we can do a post, try it out, do the nickname, this is me, doing another high score. Let's do Frogger, and it's the 1.0 version, and the score will be 123, not too big. Yes, so time is up, so I'll show the results. Is that okay? Yes. going back to here. And this is also a bit slowish, but on events, you will see all these events coming in, and you can check which events are there, and you can see that there's score received, and there's actually scores coming in. And in the application map, you should see the new component coming in if we do a refresh. But again, this is a bit sluggish, so it will come afterwards. And it's now still being, it's still looking into things, but you will see more and more of those bubbles popping up because we have our instrumentation there. Okay. That is a quick tour with everything being bundled together in Application Insights. We've covered these, so we made our systems observable by adding logging, tracing, and some metrics information. And we connected everything together to run in the cloud and to be able to see what is going on. That is what I have for you, and I believe we have a slide with the Slido questions. One question, we'll take one question. Does the logging affect the performance of an application? It does, but only slightly. But if you do a lot of logging and you do complex logging, you should bear in mind that it might be better to do some tracing. But it is overhead, so do it at the right places. You can still be more efficient if you don't have too many log providers. So yes, keep it in mind, but it doesn't affect it too much. If you have lots of tracing, you might want to look into event tracing for Windows if you're running on Windows systems, which is high performant and can do huge loads of trace messages. All right. If you have any other questions, I'll be here. You can contact me on Twitter. Thanks very much, and have a lovely rest of the conference. Here I